Hello, everyone. Today we're going to be looking at solving quadratic equations. We're going to be relying on using a graphing calculator such as Desmos. Um, so, first thing you need to be able to do is to identify how many solutions does each quadratic function have. Now, recall quadratic functions are of the form y equals some x squared. Um, and it takes the shape of a parabola, such as this one. The curve bends, and it may or may not cross through the x-axis. Remember, x-intercepts are known as zeros, they're known as roots, and they're known as solutions. So we can tell on this first one, it crosses the x-axis in two places at -2 and 0. And what you need to know is that there are two solutions. All right, you just count 1, 2. Now, if it comes down and it just touches the x-axis, then it has one solution. And then if it does not touch the x-axis, there are 0 real solutions. Now, in Algebra 2, you'll learn about imaginary numbers, and you can find imaginary solutions. But for Algebra 1, there are 0 real solutions. The graph on the right does not cross the x-axis. It doesn't touch it. All right? So, what are the solutions to the following quadratic equations? Now, we know that normally this is y equals a function, but we're setting y to 0. All right, y is now 0. And where is y 0? Along the x-axis. Okay, here we see our y values go to 6, 4, 2, down to 0. So when y is 0, it's the solution is where does the parabola cross the x-axis, okay, which goes along with what we did on the top of the page. So you just basically plug it in. So 2x squared minus 5x plus 2. Let's see. Where did I put that? 2x squared. That's right here. And you just find out where is y 0? Along the x-axis. And notice our points are 0.5, comma 0. Remember, it's x and then y. Y is 0. And then we have 2, comma 0. All right? So these are the solutions. When they cross the x-axis, y is at 0. So, but you just have to write the x values. The solution are the x values. And we don't want to use commas because then we might think we might think that 0.5 and 2 is a point, but they're separate, sorry. So the solutions are 0.5 and, don't put comma, and 2. So at 0.5 and 2, it's where y equals 0. Those are the solutions. Those are the zeros. And then you do it again for this one. And let's see, that's x plus 3 squared minus 4. Might have to zoom out to see the full picture. All right, here we have two solutions, -5 and -1. So -5 and -1. All right. Now the third one's different because it doesn't equal 0. It equals 4. So what we're going to do is we're going to change the 4 into 0 by subtraction. So 4 minus 4 will yield 0. So it becomes x minus 5 squared minus 4. And that cancels out to 0. So I come over here, and it's this one. And it yields the solutions 3 and 7. So the solutions are 3 and 7. Same thing over here on the fourth problem. We want that to be 0, so We add 4x to both sides. Remember the 4 and x are stuck together with multiplication glue. Putting it in standard form, we get x squared plus 4x plus 3, and that cancels out to 0. And you don't necessarily have to put it in standard form in Desmos. You can put it out of order like I did there. It'll be fine. The solutions are -3, -1. So the solutions are -3 and -1. Okay, so in all 4 of these problems, we were able to determine the solution by seeing where it crossed the x-axis, because the x-axis is where y equals 0. All right, y equals 0 right here. So that's the x-axis. Now, they have a note on the bottom here. In order to solve any quadratic by graphing, the equation must be equal to 0. That actually is not true. I think they probably said that just to keep things the same, but you don't actually have to have it equal to 0. And now, if you're comfortable with that, I certainly think that's good if you make it equal to 0. But just know, if you're intellectually curious, that you don't have to have it equal to 0. So let's take this x minus 5 squared equals 4. And we already know the solution is 3 and 7, right? So what if we left the 4 there? Okay, so I come over to Desmos. And let's see here at the bottom. So I have x squared minus 5. And then what was, okay, yeah, x minus 5 squared, excuse me, x. And then, okay, so instead of y equals x minus 5 squared, the y is a 4 here. So what that means is that in Desmos I can type, I'm sorry, I typed this in wrong. It's supposed to be x minus 5 squared. In case anybody was wondering, x minus 5 squared. And then you say y equals 4. And where do they meet? Now, notice how y is not 0 anymore. Y is 4. But we just want the x values. We get 3. We get 7. Oh, what do you know? That's the solutions, 3 and 7. So you don't actually have to change it to 0 if you'd rather have y equals something else. And we just found where they intersected. Where did the line y equals 4 intersect x minus 5 to the second power? Now, what about the fourth example here? So we had x squared plus 3 equals -4x. So you would come down here. Let me get rid of these. X squared. Let's see, did it say minus 3? Yeah, no, plus 3. X squared plus 3. And then, and then y is -4x. So you would type y equals -4x. And it crosses in 2 places. It crosses at -3 and -1. And what do you know? Those are the solutions, -3 and -1. So you don't actually have to change it to equal to 0. But if you're like feeling comfortable with that and just looking at the x-axis, that's totally fine. The important thing is that you get the solutions.